Hi, my name is Dayang Fatima binti Awanjur. Today I'm going to talk about impact of technology revolution to our environment. First is about tidal wave technology. Tidal wave technology is to generate electricity in areas where there is a significant tidal range. First, the positive impact is renewable and sustainable. Tidal energy is much more predictable and more reliable than wind or solar power, where wind and solar power is unpredictable. Weather can easily halt the production of natural energy. Secondly, reduction of greenhouse gases. Tidal energy contributes to a reduction in the emission of all other types of greenhouse gases, such as methane and nitrous oxide. These gases are released during the combustion of fossil fuels, such as coal, oil, and natural gas, to produce power. It also contributes to reduction of CO2 emissions by being renewable, reliable, and predictable energy source. The negative impact for the tidal wave technology is it may endanger marine life. Tidal turbines can harm marine ecosystem in a variety of ways. They interfere with the movement of sea creatures and also can trap them in their plates. They can change the water level and the levels of salt and silt in water. The underwater noise turbines produced can interfere with sea creatures' communication. Even the electromagnetic communication from power lines could affect sensitive species, causing them to avoid the area. And restricting the movement of fish reduce the food supply for marine birds, which might also relocate as a result. The second negative impact is it can cause corrosion, which means that high salinity is required in the waters where tidal energy facilities are built. So salt is known as to cause corrosion, so additional maintenance work and fees must be considered in order to avoid harmful elements going into our oceans that can also endanger marine life. Last negative impact for the tidal wave technology is high initial cost. As the tidal power is rather new, the technology required is expensive. Moreover, it's difficult for investors to make a profit from it. Next one is direct air capture, DIC technology. Direct air capture technology is technology which capture carbon directly from the air and reducing the atmospheric concentration of carbon. It is a technology that cleans the environment. The first positive impact is it is reduce atmospheric carbon dioxide, which means this direct air capture technologies extract carbon dioxide directly from the atmosphere. So the carbon dioxide can be permanently stored in the deep geological formations, thereby achieving carbon dioxide removal, which means it will reduce atmospheric carbon dioxide. Second positive impact is it can be used to remove or recycle carbon dioxide. After the carbon dioxide is captured from the air, this technology operation is aimed to either store the gas or use it to create long-lived or short-lived products. So building insulation and cement are examples of long-lived products that will bind up the capture carbon for an extended time. So using carbon dioxide in long-lived products is considered a form of carbon removal. The examples of short-lived products created with captured carbon dioxide include carbonated beverage and synthetic fuels. Because the carbon dioxide is only stored in this product temporarily, this is considered a form of carbon recycling. Next is the negative impact of direct air capture technology. The negative impact is it requires large amount of energy. This technology requires a large amount of energy to operate, and the high energy inputs are also necessary to produce the materials required for the technology process and to heat sorbent materials for use. Last negative impact is it requires expensive costs. The variation in costs are based on what type of energy is used to run the direct air capture technology process, whether liquid or solid sorbent technology is used, and the scale of the operation. Since carbon dioxide is not very concentrated in the atmosphere, it takes a lot of energy and therefore is very expensive to remove. The last impact is the electricity produced by solar panels. Solar panels is a photovoltaic cells mounted in a framework for generating energy, which use sunlight as a source of energy to generate direct current electricity. The positive impact of electricity produced by solar panels is it can reducing carbon footprint, which means that solar power reduce carbon dioxide emissions by providing a clean and renewable source of energy. The panels that are installed on that can collect the energy from the sun and convert it into usable electricity. This process does not rely on fossil fuels or other products, and none of the energy is wasted because it can be stored on the grid of future use. So it will reducing carbon footprint. The second positive impact is reduce water pollution. You might be wonder why solar panel can reduce water pollution. The solar energy reduce water pollution because the photovoltaic cells panels does not need water to operate as other manufacturing processes do. So the sunlight is converted into electricity without the need for water supplies, and solar energy doesn't pollute our waterways like fossil fuel too, because the mostly other technology it requires water to produce energy. So the next one is a negative impact for the solar electricity produced by solar panels. The first negative impact is it needs a lot of space. So the more electricity you want to produce, the more solar panels you will need, right? So as you want to collect as much as sunlight as possible. So solar panels require a lot of space, and by altering present land use, a solar farm may also lead to degradation of land due to exploration, extraction, manufacturing, and disposal of solar panels, and this will cause deforestation. The last but not least, the negative impact for electricity produced by solar panels is the manufacturing process involve harmful chemicals. So by manufacturing these solar panels, there are many hazardous chemicals that used to make these photovoltaic cells and panels that must be carefully handled to avoid release to the environment. Some types of photovoltaic cell technologies use heavy metals, and this type of cells and panels may require special handling when they reach the end of their useful life. So some solar thermal systems use potentially hazardous fluids to transfer heat, and leak of this material could be harmful to the environment. So that's it from me. Thank you.
Hi, my name is Nadia. I will be talking about computers' creative destruction. 3 long arrangements and assumptions must be destroyed to free up resources and energy to be deployed for innovation. First, solar energy. It is the most abundant of all energy resources. Solar panels are more efficient, affordable, and environmentally friendly than fossil fuels. However, the manufacturing of solar cells require a lot of energy and toxic chemicals, which are dangerous to our environment. While installation of solar cells require a lot of space, that means we have to cut down trees and sacrificing our land to build the solar panels. Also, solar panels are dependent on sunlight to function effectively. So during the night, there is no sunlight and thus no energy collected. Based on computers' theory, solar energy can replace fossil fuels as an alternative energy because it emits less greenhouse gases and thus save our Earth. Next, practicing installing solar panels on the rooftops of houses or buildings, which also known as brown solar panels. It allows us to save lands for other beneficial uses. Also, we can use it for diverse purposes, such as generate electricity and heat. Next is wind energy. It is clean energy source, which means it doesn't cause air pollution as it emits less to no dangerous greenhouse gases. However, building its turbines requires a lot of spaces and need to be at the limited area like countryside. And it tends to generate a lot of noises which can be unpleasant to us, that leads to noise pollution. From computer theory, wind energy can reduce our reliance on fossil fuels as it can provide electricity without burning fuels. Next, it is energy secured. It has a special ability to quickly absorb, store, and re-inject electricity. Other than that, it can create employment opportunities, whereas the number of labor required is high to build turbines. Also, the surrounding area of wind farm can be a new source of income in terms of agriculture. So farmers now can consider how they might make use of their land to farm wind. And gain more money.
Thank you, Ms. Nadia. My name is Hafiz with metric number 75513. Based on the journal in the browser, the planet will approach peak oil eventually. Some scientists expect peak oil will come by 2050. Many sectors are focused on finding alternatives to petroleum for global energy needs. To avoid this crisis, biodiesel was introduced. We can see an example from the neighbor country, which is Indonesia. They produce locally. It supports their economy and promotes social development nowadays. Basically, biodiesel is manufactured from palm, soybean, canola, and corn oils. It's cleaner and more sustainable than petroleum fuel. In addition, biofuel burns cleaner than gasoline, reducing greenhouse gas emissions. Biodiesel's carbon dioxide emissions are compensated from biomass resources absorbed by growing soybeans or other feedstocks. It's a renewable and sustainable energy source. Based on my research, Argonne National Laboratory and CRB Corp concluded that switching from petroleum to biodiesel may lower carbon dioxide emissions by 74%. In short, it is categorized as one of the green technology as it's parallel with the definition and the objectives. And from the ideology of Schumpeter, creative destruction, we can relate that replacing petroleum fuel to a biodiesel biomass is unpreventable since global warming is nearly come to high end. Besides, developing new machines toward innovation replacing the old technology such as oil rig and drilling machines that harms the sea and the land. Not to mention, the evolution of biodiesel eventually create new jobs as well as in economic structure in the long term. However, on the downside, it will eventually eliminate the low-skilled workforce from the market. Hence, these are the proofs with the theory creative destruction from Joseph Schumpeter. Thank you for listening.
Nanotechnology is science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. Nanotechnology is a subject which has been popular within the scientific and technology industries for many years. This has been branded as green nanotechnology since it focuses on challenges within the nanoscale that need to be overcome to ensure eco-friendly processes and products. Objectives of nanotechnology are to create eco-friendly designs with nanotechnology and use it to reduce health and environmental hazard by seeking methods to replace present applications with green nanotechnology products. So now let's move on to the next point, which is, does size matter? So size does really matter. The size of 1 nanometer is 1 billion of a meter, which is about 100,000 times smaller than the width of a human hair. The illustration shown has 3 visual examples of the size and the scale of nanotechnology, showing just how small things at the nanoscale actually are. So green nanotechnology is an application of nanotechnology, which is the branch of engineering that deals with things smaller than 100 nanometers. So it refers to heighten the environmental sustainability that is producing negative exteriorities. For the sustainability enhancement, green nanotechnology also refers to the use of nanotechnology products. Green nanotechnology is basically about making green nanoproducts or doing things right in the first place. Green nanotechnology also refers to the application of green chemistry and green engineering principles to nanotechnology to evolve methods, materials, and techniques for diverse applications like generating energy to non-toxic cleaning products. So green nanotechnology is likely to result in manufacturing processes that are more environmentally friendly and more energy efficient. A green nanotechnology is also a sustainable approach to nanotechnology from design to production and product use to disposal or recycling. There are 2 key aspects to green nanotechnology, which involves nano products that provide solutions to environmental challenges. And the second one is producing nanomaterials and products containing nanomaterials with a view toward minimizing harm to human health or the environment. So now let's talk about green nanotechnology tributes to renewable and sustainable energy. Solar is the one of the tribute from the green nanotechnology. Silicon-based solar panels, which accounts for about 95% of commercial solar, utilize nanoscale processes for manufacturing. Some are multi-junction solar cell, which layer different solar technologies to broaden the wavelengths of the light that are captured and converted into energy. This layered cake of solar cell technologies are measured in nanometers. There are two examples of solar, which are quantum dot solar cells and perovskite solar panel. Quantum dots are semiconducting particles that behave differently due to their size and the effects of quantum mechanics. In June 2020, researchers at the Los Alamos National Laboratory were able to create cadmium-free quantum dot solar cells. The second one is this year, researchers at the University of Queensland were even able to break a new world efficiency record of 16.6% for a quantum dot solar cell made from a halide perovskite. In 2014, researchers at the University of Sheffield were able to develop a spray-on solar cell using perovskite, which is a class of man-made compounds that share the same crystalline structure as the calcium titanium oxide mineral with the same name. So it consists of a 300 nanometer thin film with a crystal structure that adds solar absorption and can operate efficiently during cloudy days as well. So for the final one is it should also help to reduce the cost of manufacturing solar technologies, which will make it more accessible. So that is all from me. Thank you.